Hey there, I'm Ken. This is Canadian Retro Things. Welcome. It's time to play with my TRS-80 Model 1 some more. I know. I said that I was going to continue opening up those boxes. I still have 4 boxes of stuff to open. But I got reading that technical handbook, and yeah, there's just some stuff that I just can't wait to try to see if I can maybe isolate the problem with this computer. And I also have to give a big apology to the person that donated this computer to me. I said his name was Sheldon McDonald, and I know very well it's Shane McDonald. Yeah, seems to be a problem that I'm having more and more in my life right now, that my brain thinks one thing, my mouth says another. So, sorry, Shane, not Sheldon. All right. So, yeah, we're going to isolate first whether it is actually the computer that's a problem or whether it's the monitor. And then we're going to get out and test a few different things on the board and see if we can see any problems there. But first, I have to give a big thank you to the sponsor of today's video, PCBWay. PCBWay, where you can have PCBs printed for as little as $5 for 10 boards. If you're a retro collector and you like to fix your own computers, chances are that you will eventually find a broken chip that is hard to find. You could pay huge prices online for one that might work, but if you're lucky, there's a modern replacement. Unfortunately, those don't always fit and they need an adapter board. PCBWay can make those for you starting at $5 for 10 boards. The design might already be in their shared projects, so all you need to do is click and buy. So why not try PCBWay today by visiting www.pcbway.com and PCB prototype the easy way. So to test that it is the computer that's not working and not the TV, I'm actually going to hook the computer up to a different TV. Now I can hear you asking, how am I going to do that since the video output is a 5-pin DIN, which is built into the video display unit? Well, let's get a little closer here, and we can see, let me grab something to point with here. Here you've got your 5-pin DIN, so there's 5 pins in here, and pins 4, what is it? Yeah, 4 and 5, so that's that pin and that pin, are a composite and a ground pin, which means if you only hook up those two, then you basically just have a regular composite output, which you can hook up into a regular TV. So, if you want to test it on the board and know which one is which here, I just have a wire here. I'm going to plug it in. So I have the wire plugged into the pin that is closest to the power connector. And in the handbook, it says that this right here on this giant capacitor is the best spot to ground for this board. So there we go. That is the ground. The ground is the closest to the power connector. So now let's make a little redneck connection to a composite cable and get going on this. You may remember I did a very similar thing when I had that Magnavox 500 last year that I picked up at Boat Fest, and it has a proprietary connector, so I just used some wires onto a regular composite cable, and let's do that again. All right, my redneck connection is made right here. So it is time to turn this on and see if anything happens on the TV. All right, here goes nothing. Yeah, this should theoretically work, so I would guess we're getting no output of a video signal here. So the next thing we're doing is a power supply check and, if needed, adjustment. And yes, this wonderful technical manual actually gives you step-by-step instructions, where to test the board, how to test it, how to just, I mean, it's wonderful that Radio Shack was a company that supplied books like this if you wanted them, so that you could actually work on your own product here. Something that you don't see a lot nowadays. As a matter of fact, most companies are trying to prevent you from doing, and Radio Shack encouraged it. All right, I'm going to do everything that it says to do in the book here. So connect the common lead of the digital voltmeter to the right side of capacitor C9. This is C9. So we connect you to the right side. And I guess we're doing DC voltages. Now for the 12 volt supply, measure the voltage present at the top side of power resistor R18. Top side would be the closest to the edge of the PCB. So there's a nice little picture here. R18 is where? That's this guy right here. So we shall turn this on. And test at R18. That's not good. We're not getting 12 volts at all. What about our 5 volt? So this should be 5 volts right here. I'm a complete and utter moron. I haven't plugged the power supply in. All right, the power supply is now plugged in, so now let's see what voltages we're getting. Wow, 12 volts on the dot. And 5 volts. 5.29. So that's a little bit high. You know what? I can adjust that. All right, it is time to adjust this. I have my little ceramic adjuster here. So let's plus or minus 5%. So there's well within range, but let's get it to there we go, about 5 volts. Has that made a difference? Probably not. But let's check it out anyway. Okay, so I plugged in the monitor, tested it out, and I didn't get any change. So one thing I have not tested yet is the negative 5 volts. And it says here to measure the voltage at the anode of CR2. CR2 is located to the left of the power switch. Voltage should be negative 5 volts plus or minus 5%. There's no adjustment for negative 5 volt power supply. If the supply fails to fall within the voltage range, you must isolate the problem to a defective component. So negative 5.1213, that is well within range. All right, well, voltages are correct. Okay, I have my oscilloscope hooked up. Power is on. Let's just see what we are getting as an output here. Okay, we're getting something there. So we are getting just a steady little pulse coming out of the video out here. So let me just... To me, that looks very much like it could be a sync signal. Let me just be right back. I'm going to look through the book. And looking through the reference manual, actually, I'll just screen capture this diagram here. And we can see that I'm basically getting... looks like a vertical sync, so I'm not getting any horizontal sync. I'm also not getting any white level, which the white level would be it printing any words onto the screen. So it looks like we're completely missing everything that happens during the horizontal sync, and we're only getting a vertical sync. So I guess we will now start tracing back and see where all the horizontal sync stuff happens and see if we can find a problem there. If you're watching this video, then chances are you like retro. If you have a Tandy color computer, a VIC-20, a Commodore Plus 4, 16, 64, 128, or Amiga, then I would suggest checking out Retro Rewind. They sell hardware, diagnostic cartridges and accessories, capacitor kits, and they will even recap your board for you. So for all of your Commodore and color computer needs, visit Retro Rewind at www.retrorewind.ca. And if you use my discount code of CRT10 at checkout, you will save 10% on your order. Check out the link in this video's description. I've pretty much come to the conclusion that we have no horizontal sync. At least that is the assumption I'm going under. So I pulled out the schematics and I backtraced the horizontal sync line. Now, mind you, this was all on one giant piece of paper for me, so it was easier to follow. But the line runs from, I believe its origin point is on Z50, pin 11. From there, it goes to pin 14 on Z12 and pin 8 on Z30. It's also joined by pin 4 from Z66. Keep following that same line that comes out of Z50 pin 11 all the way over to Z6. It goes into pin 13, out pin 12, into pin 1, and out pin 2. Then goes to Z5, into pin 13, out to pin 11, into pin 10, out to pin 8. Also on Z5, it goes in pin 2, out pin 3, into pin 12, out 11, in 10, out 8. So it just goes in and out of a whole bunch of pins on Z5. So I'm going to be testing a lot of stuff on Z5. But let's just start testing at Z50 at the very beginning, I hope. So I believe Z50 is under this ribbon cable right here. So I need pin 11. 8, 9, 10, and 11. Okay, that actually looks good. Into Z12, pin 14. Z12, pin 14. 8, 9, 10. Try to do this without blocking the... Yep. Same signal. Z66, pin 4. It's the one that joins the line. Pin 4, we're just getting a ripple on there. Oh, wait, Z66. That's this one. Okay, we're getting the same signal there. Into Z30, pin 8. Then it goes all the way over to pin 13 on Z6. Okay. And out pin 12. Okay. Into pin 1. Yeah. Out pin 2. Okay, now we are going to check Z5 pin 13, which is this guy right here. Okay, we've got a signal. Comes out 11. Okay, we're flatlining there. I don't know if that's actually just supposed to be something low, but so 11 should come in 10. And out 8. Okay. And then we go pin 2, out 3. Okay. In 12, out 11. So in 12 and 11 we know it's flat. Whoa. We know that's flat, so thinking that might be a problem. Then in 4, out 6. In 9, out 8. In 4, out 6. Okay, we're getting a signal there, and out 8. Yeah, so everything is getting reversed. But just a second, I think I saw something in the book here. All right, I have a chart here that I will put up on the screen showing some of what should be coming out of pins on Z5. So pin 3. See if that matches up. We'll change... Change the time, and yes, pin 3 looks about right. Pin 11. It's 14, 13, 12, and 11. 11 is our flat line one. And 11 should not be flatlined. Pin 6. That doesn't look quite right on pin 6 either. Pin 8, obviously, that's our output. And yeah, we're not getting what we're supposed to. So definitely that pin 11 is not giving us what it should. I think that would be a good candidate for what might be a bad chip. Okay, so I found at least one major problem with this computer. I seem to have a horizontal sync going through the computer until it hits Z5, and there it terminates. So that would mean Z5 is most likely dead. So I hope it's as easy as replacing that chip. I did look at some other videos where people had similar problems with their TRS-80 Model 1s, and Z5 is one of the problems that some people had. So it sounds like that could very well be a common thing. So hopefully, yeah, hopefully it's going to work when I replace that. That's the easy thing, is just replacing it. The hard thing is going to be tracking down a 74C00. I have a ton of 74LS00s, but no C's. So yeah, hopefully it's not going to cost me an arm and a leg to get a hold of one, or hopefully I'm not going to have to order it from someplace like AliExpress and wait 6 months to get it. As a matter of fact, I'm going to be at VCF Midwest in the beginning of September here. And hopefully, if one of you watching this video happens to have a 74C00 chip, come by my table. I would gladly buy it off of you. Alright, so I hope you enjoyed this video. Probably next week we are going to finish unpacking everything that I have to go with this computer. And yeah, a big thank you to the sponsor of the video, PCBWay, and the sponsor of my channel, Retro Rewind. Don't forget, if you're visiting Retro Rewind, then use CRT10 at discount to get a 10% discount at checkout. All right, so don't forget, like, subscribe, comment, all that YouTubey stuff. It's greatly appreciated, helps the channel out a ton, and I will see you next time. Maybe I'll even see you at VCF Midwest.